Hey guys, a quick video on nitrogen and sulfur. Let's begin. Alright, nitrogen. Now nitrogen is in group 5. That means it has 5 electrons in its outer shell. Nitrogen normally will exist as N2. Now it's making a triple bond over here, sharing 3 electrons each from each nitrogen. Nitrogen on the left electrons are donated by a dot, and across is the electrons from nitrogen on the right. And this triple bond, because there are 3 of them, becomes very strong. That makes nitrogen N2 very inert because it takes a lot of energy to break these bonds. It takes a lot of energy. So on its own, nitrogen is pretty inert. That's why it doesn't react with anything, even though air is 78% nitrogen. The triple bond makes it very inert. Now you'll normally see the triple bond denoted as 3 bonds over here. So the bond in this middle is a sigma bond, and the 2 bonds on the side are 2 pi bonds, right? We'll see some times that this bond does end up breaking. It can break in regions where there's a lot of energy, like because it's in the nitrogen is present in the atmosphere, lightning can end up breaking this bond and it forms oxides. And internal combustion engines, they intake air, and over there these bonds can end up breaking and end up forming oxides, which end up turning into pollutants. And we'll take a look. Nitrogen reacts with hydrogen to form ammonia, NH3. Now ammonia has 3 bonds. Nitrogen is bonded to 3 hydrogens, and it makes a trigonal pyramidal shape, bond angle of 107. Hydrogen over here is bonded directly to nitrogen, which is one of the top 3 electronegative elements in the periodic table. So this ends up forming, well, not this, but hydrogen now can, and nitrogen even, can end up forming hydrogen bonds with other molecules that can also form hydrogen bonds. So that makes ammonia soluble in water. When ammonia reacts with water, it forms an ammonium ion and also OH ions, which makes it a base. Now, because it's a base, ammonia can also react with acids to form a salt. Now this is known as an ammonium ion. It has a positive charge and it's bonded to 4 hydrogens. When ammonia gains a hydrogen, the bonding is slightly unique. It forms a bond with the lone pair. Now how does that happen? Now let's first look at just ammonia. Ammonia already had 3 bonds with hydrogen. Nothing special. It had a lone pair on top over here. That lone pair ends up forming a dative bond with a hydrogen with a plus charge, just a proton, no electrons. So the overall molecule ends up getting a positive charge. And this is important. You have to show that ammonium ion has a positive charge with a bracket and a plus sign on top. Now, the dot and cross diagram is going to look like this. So it has an electron from nitrogen and electron from hydrogen. And these aren't datively bonded because these were already there. These are covalently bonded. And the last one is going to be a dative bond. And you have to show this by showing both electrons are from ammonia. Again, the dot is nitrogen's electrons. And you have to show that it has an overall positive charge. Ammonia is a very useful compound. It helps us make ammonium sulfate, ammonium nitrate, phosphate, even urea. These are all fertilizers, very helpful. So one great use of ammonia is fertilizers. Another use of ammonia is to make nitric acid, which helps us. So it has a lot of industrial properties. Nitrous acid is HNO3. Uses of nitric acid include making explosives, polymers, drugs, TNT. Now ammonia is very soluble. It's great for organic plants and everything, but because it's very soluble, it gets washed away. Now, once it gets washed away, it ends up in oceans and lakes and whatnot, and it promotes a lot of life there. A lot of algae is produced. Now, algae is at the surface of the water, right? So it prevents a lot of sunlight from reaching through the surface and reaching on the plants. The plants end up dying because of lack of sunlight, and because of the decay, that promotes a lot of bacteria which eat up take all the oxygen in the water and decrease oxygen levels. Now, because the life underwater requires dissolved oxygen, that goes down and they end up suffering. They end up dying as well. And this is called eutrophication, and it's very bad for the environment. Nitrogen has two oxides, nitrogen monoxide and nitrogen dioxide. Now, nitrogen monoxide can react with oxygen to turn into nitrogen dioxide. Nitrogen monoxide is produced in the combustion engine, where high temperatures break up the nitrogen-nitrogen triple bond, and it ends up reacting with oxygen. Now, in the atmosphere, once it escapes, it can further react with oxygen to form nitrogen dioxide. Now, nitrogen dioxide is a pollutant because it can react with sulfur dioxide in the atmosphere, another pollutant, to form sulfur trioxide. And because it doesn't just react, it catalyzes the reaction. Nitrogen monoxide is formed again. Now, nitrogen monoxide can further react with oxygen to form nitrogen dioxide again. And this process keeps on repeating itself. Now, why is this a pollutant? Is because sulfur trioxide can react with water in the atmosphere to form sulfuric acid, and nitrogen dioxide can form nitrous acid. Both of these combined, we can prevent all of this from happening when we prevent nitrogen monoxide from entering the atmosphere. We do this by, when they're formed in the combustion engine, we make sure they go through a catalytic converter in the exhaust and react with carbon dioxide to form nitrogen and carbon dioxide. Earlier I meant carbon monoxide. And the catalyst for this reaction is platinum. And to balance this equation, you need twice the amount of nitrogen monoxide. Sulfur is from group 6 of the periodic table. That's why it has 6 outer electrons. And when sulfur forms a molecule, it forms a molecule with 8 atoms. Sulfur has two oxides, sulfur dioxide and sulfur trioxide. And they're both pollutants, and we just saw how they end up polluting our environment. The shape of sulfur trioxide is trigonal planar, and the bond angles are 120 degrees. For sulfur dioxide, we can't really figure out what the shape is because we haven't done this yet, but it's very reminiscent of the trigonal planar structure because it has very similar structure, but there's no third bond over here. So we don't have a name for it, but we can predict its bond angle. It's going to be very close to 120, but slightly lesser. So about 117 is a good answer. Coal contains a lot of sulfur, and when we burn coal, a lot of sulfur is burnt as well, and that enters the atmosphere, which can end up causing acid rain.